So imagine a single line of code updating in the cloud on just some random Tuesday night.
Right. Happens all the time.
Yeah, but then by Wednesday morning, $1 million batch of like a life-saving chemotherapy drug has to be thrown straight into the incinerator.
Which is just a devastating scenario.
Completely. And the truly tragic part, the drug itself was perfectly formulated.
Wow.
Yeah. The problem was that the software tracking its incubation temperature wasn't legally proven to be accurate after that overnight patch.
And that right there, I mean, that highlights the severe friction we see every single day in life sciences.
The stakes are just incredibly high, right?
Existential, really.
Mm.
A glitch in these environments doesn't just, crash a spreadsheet. It compromises patient safety, it adulterates products, and it can completely invalidate years of clinical trial data.
So you really don't have the luxury of that whole Silicon Valley move fast and break things mindset.
Oh, absolutely not. Because when a broken system means a regulatory shutdown, you can't afford to break anything.
Right. And that collision between the agile, constantly updating world of modern software and the zero-tolerance reality of regulated industries is exactly our focus today.
It's such a crucial topic.
It really is. We are taking a deep dive into a comprehensive framework published by Validfor. It was written by their CEO and co-founder, Omer Seaman.
A really fascinating read.
Yeah, and the subject is Computerized System Validation, or CSV. Now, since you listening are likely already living and breathing in this space, our mission today isn't to rehash like basic definitions.
Right, we're skipping the 101 stuff.
Exactly. We want to unpack the modern friction points, like how do highly regulated organizations actually maintain operational resilience when the underlying technology just refuses to stand still?
Well, Siemens Guide frames CSV not as this bureaucratic hurdle, but really as the core engine of operational control.
Okay, let's unpack this a bit.
So if we look at the current landscape of digital transformation, the challenge is no longer about validating some massive monolithic on-premise system once every 5 years.
Because those days are pretty much gone.
They are. The true challenge now is maintaining a continuous state of validation across a highly fragmented, constantly evolving digital ecosystem. I mean, we're talking SaaS platforms, APIs, mobile interfaces.
Let's dive straight into that friction, actually, because the word validation inherently sounds like, I don't know, a final destination.
A one-and-done deal.
Right. You run the protocols, you gather the digital signatures, you generate your summary report, and bam, you declare the system validated.
Put a stamp on it and walk away.
Yeah, exactly. But reading through the Validfor piece, the entire concept of treating CSV as this static pre-go live documentation dump is framed as a massive liability.
It's an unsustainable liability. I mean, if an organization treats validation as a static state, think about what happens the second a cloud vendor pushes a mandatory security update.
Which realistically could happen just hours after a system goes live.
Precisely. And the moment that happens, that organization is technically operating an unvalidated system. Yeah. So Seaman really emphasizes that the industry has to shift to a living lifecycle model, and that relies heavily on structured, continuous change management.
Okay, so I hear a phrase like structured change management, and I immediately think about the practical bottlenecks.
Sure.
Let's say a pharma company is running a cloud-based enterprise resource planning system, right? And that vendor pushes a mandatory patch over the weekend.
Happens every month.
Right. So how does the company survive that without completely paralyzing their operations? I mean, you can't put a freeze on manufacturing while a QA team spends 3 weeks running manual regression scripts just to prove the system still works.
No, you definitely can't. And what's fascinating here is that the survival mechanism in that scenario relies entirely on digital traceability.
Traceability, okay.
Yeah, a modern lifecycle approach means you aren't rerunning the entire validation package from scratch.
Thank goodness.
Right. Instead, you maintain a digital thread. This thread links your initial system requirements directly down to your testing protocols and your relief procedures.
So it's all mapped out in advance.
Exactly. So when that vendor update hits, the IT and quality teams don't panic. They perform a highly targeted impact assessment.
Ah.
They trace the specific code or configuration change down to the requirement level just to see what is actually affected.
Okay, so it's really about isolating the blast radius of an update before you even write a single test script.
Yes, you are essentially asking a very pointed mechanical question. Does this specific patch touch any function related to patient safety, product quality, or data integrity?
And if it doesn't?
If the technical assessment proves the answer is no, You document that rationale, update your configuration matrix, and release the system. Done.
Oh, wow, that's so much faster.
But if the answer is yes, well, that triggers a predefined automated regression test, or maybe a targeted requalification of only the affected modules.
That targeted approach leads us right into the actual mechanics of the qualification process itself.
The alphabet soup, as some call it.
Yeah, the classic blueprint. The Validfor guide walks through user requirement specifications, functional specifications, and then that standard progression of installation, operational, and performance qualification.
The famous IQ, OQ, and PQ.
Right. Since you, listening, probably know these acronyms in your sleep, let's look at where these phases actually break down in practice. Like, how do these traditional phases adapt to agile pipelines and CI/CD where code is just being deployed continuously?
Well, the breakdown almost always occurs at the transition between operational qualification and performance qualification.
Really? Why that specific gap?
Historically, you have a siloed IT department or maybe a dedicated validation team that handles the OQ. They prove the software functions according to its technical design specs.
Basically proving that the buttons do what the manual says they do.
Exactly. But performance qualification, the PQ, that requires proving the system works in its actual operating environment alongside real business processes.
Oh, I see.
And in a continuous deployment scenario, keeping those two phases completely separated creates a massive bottleneck.
To make that concrete, imagine buying a high-end commercial oven for a bakery. The IQ is making sure the electricians wired it right. The OQ is checking that when you turn the dial to 400, it actually hits 400 degrees.
I love this analogy.
Right. But the PQ has to prove that during a chaotic dinner rush, with multiple chefs opening and closing the door, it can consistently bake your specific delicate souffle without ruining it.
Exactly. And achieving that level of proof requires a fundamentally different approach to testing.
Because you can't just test the dial anymore.
No. The OQ can rely heavily on automated regression testing pipelines. But the PQ often requires integrating those automated tools with user acceptance testing. You have to simulate edge cases with the actual business process owners.
Which sounds incredibly time-consuming.
It is. And the danger Simon highlights is that companies frequently over-engineer this phase.
Like, they test everything all the time.
Exactly. They treat every single button on the user interface as if it requires a fully documented manual PQ script.
Which brings us to what might be the most critical paradigm shift discussed in the source material, and that's the move toward risk-based CSV.
A total game changer.
Because if an organization is running like fully documented PQ scripts on an update that just changes the font color on a reporting dashboard, they are burning resources for literally zero compliance gain.
Worse than that, over-validating actually introduces new compliance risks.
Wait, really? How does testing too much create a risk?
If we connect this to the bigger picture, think about human psychology. If a quality team generates 1,000 pages of test scripts for low-risk functions, they develop severe alert fatigue.
Oh, like they just stop paying attention because it's so tedious.
Exactly. A subtle, dangerous flaw in a critical algorithm could easily slip through because the reviewers are just buried in screenshots of low-impact UI testing.
That makes a lot of sense.
So a risk-based approach forces the organization to allocate its intellectual energy toward the functions that actually govern the system's compliance.
Okay, we hear focus on high-impact areas all the time in this industry. But I want to understand how a company legally justifies that to an auditor.
That's the million-dollar question.
Right, like what is the actual mechanical framework a company uses to prove they didn't need to formally test a specific function?
The primary mechanism is a formal framework like a failure mode and effects analysis, the FMEA.
Okay, walk me through how that works in this context.
Long before any test scripts are written, cross-functional teams sit down and map out the system's requirements. They assign each one a risk priority number.
So they're literally grading the risk.
Yes. They evaluate the severity of a potential failure, the likelihood of that failure occurring based on the system architecture, and then the probability that the failure would go undetected by existing controls.
So if a secondary reporting tool fails, the severity is low because, well, the data can still be queried manually from the database.
Exactly. No one is getting hurt.
But if an automated batch release mechanism fails, the severity is critical because adulterated products could literally be shipped to distribution centers.
That is the core logic.
Yeah.
And this lines directly with the industry's broader transition from traditional computerized system validation to computer software assurance, or CSA.
CSA, right. I've seen that term popping up a lot more lately.
CSA principles basically flip the old model on its head. Instead of defaulting to heavy scripted testing with hundreds of screenshots for every single feature, you default to critical thinking.
So less busy work, more brain power.
Exactly. You leverage the software vendor's own testing documentation for baseline functionality. And you reserve your rigorous custom scripted testing exclusively for high-risk custom configurations.
I feel like that shift requires a ton of trust in the vendor, though.
It does.
Because if you're using an off-the-shelf SaaS application from a reputable provider,
Right.
retesting their core code on your end is just redundant paperwork.
Completely redundant.
So the focus has to be on how your specific configurations and custom workflows interact with that underlying code.
And the regulatory bodies actually actively encourage this.
They do.
Yeah, you justify the reduction in heavy testing by pointing to your vendor audit and your internal FMEA. You present that risk assessment to the regulator and demonstrate that, hey, because this function poses no direct risk to product quality or patient safety, unscripted, ad hoc testing was sufficient.
And auditors are okay with that.
That is entirely acceptable under modern guidelines, provided, of course, that the rationale is documented up front.
Bringing the regulators into the conversation is so crucial here because, let's be honest, risk-based testing only survives contact with reality if the auditors actually agree with your risk assessment.
Very true.
The Validfor guide references all the major regulatory frameworks. You've got FDA 21 CFR Part 11 in the United States, EU Annex 11 in Europe, and industry guidance like GAMP5.
The heavy hitters.
Yeah. When an FDA investigator sits down in a conference room to review a system, they aren't, like, reading the raw source code.
Well, definitely not.
So what specific mechanical realities are they hunting for?
They are hunting for irrefutable control and traceability over the electronic records. And this almost always centers on data integrity.
Ah, data integrity, the golden rule.
Always. The industry relies heavily on the ALECOA plus principles.
Right, dictating that data must be attributable, legible, contemporaneous, original, and accurate.
Exactly. But from an auditor's perspective, they don't just want you to recite the acronym. They want to see the underlying technical architecture that actually enforces those principles.
Okay, let's go deeper than just defining the acronym, because we all know the theory of LCOA plus A. But how is that actually achieved mechanically within a complex cloud environment?
Mechanically, it relies on immutable cryptographic audit trails.
Immutable meaning it cannot be changed under any circumstances.
Correct. If a value in a database is modified, the system must automatically record who changed it, the exact timestamp, the original value, the new value, and the reason for the change.
That's a lot of metadata.
It is. And crucially, that audit trail itself must be logged at the relational database level.
Why the database level?
So that a system administrator, even someone with super user access, cannot silently alter, truncate, or delete it.
Ah, so it's far beyond just generating a simple text log file.
Miles beyond.
It requires logical security controls and metadata locking that physically prevent tampering, even from users with elevated privileges.
The investigators are specifically looking for that logical security. They evaluate how electronic signatures are linked to the individual user profile.
Making sure someone isn't just sharing a generic login.
Exactly. They check if application sessions time out appropriately. If a user generates a PDF report from the system, the auditor will check if the metadata embedded in that file is secure.
So they're probing for weaknesses.
Right. They don't expect absolute perfection in system design, but they demand absolute proof that you have mapped out the data flows and implemented technical controls that make silent data corruption practically impossible.
Which naturally brings us to the human element.
Always the wild card.
Seriously. I mean, we can engineer the most robust, cryptographically secure, fully validated system in the world, and then a human being logs in.
And that's where the real test begins.
Right. So how often does a technically flawless system fall out of compliance simply because of user behavior?
Honestly, it is the most common point of failure.
Not the code, but the people.
Yep. The Validfor guide makes a really pointed argument here. They say that training is drastically underestimated as a validation control.
I feel like organizations frequently view system training as just like a basic onboarding checklist for HR.
Like a video you watch on your first day and then forget about.
That's exactly.
But in a regulated environment, documented, role-specific training is required evidence of ongoing systemic control.
So an untrained user isn't just inefficient, they represent an active compliance breach.
They completely invalidate the system's operational state.
Wow.
Consider a scenario where an IT administrator doesn't quite understand the regulatory impact of a configuration menu. They might tweak a user access role on a random Tuesday afternoon just to help a lab technician access a specific module they need.
Sounds harmless enough, just being helpful.
Right. But that seemingly minor configuration change might silently bypass the segregation of duties requirement, which instantly compromises the validated state of the entire application.
Oh, man. And the technology did exactly what it was instructed to do.
Flawlessly.
The failure was entirely in the human understanding of the system's regulatory boundaries.
Which is exactly why auditors demand training records right alongside the validation test scripts.
They go hand in hand.
They have to. If the people operating the system don't understand the workflows they're supposed to follow, or, more importantly, why those specific workflows exist, then the validation package is effectively meaningless.
A perfectly built car being driven by someone who doesn't know what a stop sign is.
Exactly. The human is the final and really the most vulnerable node in the validation lifecycle.
Pulling all of these threads together, I mean, the core takeaway from Omer Simmons' framework seems to be that computerized system validation is definitively not just a hurdle you clear so you can launch a software and forget about it.
No, the launch and forget era is over.
It has to be an ongoing dynamic strategy. It requires structured change management, risk-based critical thinking rather than just blind test execution, and continuous education for the humans actually pushing the buttons.
Beautifully summarized.
And overcoming the friction of modern CSV requires organizations to just abandon those fragmented documents and manual review cycles and embrace fully connected digital validation processes.
That continuous digital integration is truly the only sustainable path forward. As these ecosystems become more complex, relying on the old paradigm of static validation will simply break the business.
And speaking of things becoming more complex, as we look toward what comes next for that life cycle, there is something really fascinating hidden in plain sight on the Validfor site itself.
Well, I know exactly what you're going to bring up.
Right. If you look closely at their footer, it is just packed with policies regarding Validfor AI, LLM usage, and the EU AI Act.
Which signals a massive, massive paradigm shift on the horizon.
How so?
Well, think about everything we've discussed today. IQ, OQ, PQ, automated regression testing, FMEA. It all relies on one fundamental deterministic assumption.
That the software behaves exactly the same way every time.
Precisely. Traditional software validation assumes that if you feed a system the exact same input, it will process it using the exact same hard-coded logic, and it will generate the exact same output every single time.
And that absolute predictability is the literal bedrock of compliance.
It is.
But large language models and generative AI, I mean, they operate on probability and vector mathematics, not hard-coded logic.
Right. They are non-deterministic by design.
They are engineered to adapt, to learn, and to generate novel, unscripted responses.
And that is the most provocative question facing life sciences right now. How do you approach that reality?
Yeah, how do you validate a system that is engineered to evolve?
Exactly. How do you write a performance qualification protocol for a machine that might provide a more nuanced, technically different answer tomorrow than it did today?
Because if you can't rely on absolute reputability, the entire framework we just spent 20 minutes talking about has to shift.
It has to be rebuilt from the ground up.
You'd have to validate the boundaries, I guess, the guardrails and the training data of the AI, rather than just testing for a specific, predictable output.
It forces the industry to completely rethink what the word control actually means in a digital context. The continuous lifecycle approach we've been talking about, it won't just be a best practice anymore.
It'll be mandatory.
It will be a mandatory survival skill in an AI-driven regulatory landscape.
Yeah,
you won't just validate the output, you will have to validate the learning mechanism itself.
Wow. Well, on that staggering thought, we are going to wrap things up. Thank you for joining us on this deep dive. As always, keep asking questions, look beneath the surface of the systems you rely on every day, and we will catch you next time.